Contributions of Aryabhat-Astronomy. He made incredibly accurate calculations of the length of the day and the year. Aryabhat calculated the circumference of the Earth as 39,968 kilometers, while the actual circumference is 40,075 kilometers. Thus, Aryabhat's value of the size of the Earth is only 0.2% smaller than the actual size. Aryabhat also put forth impressive calculations regarding the sidereal rotation. Rotation calculated by referencing the position of the fixed stars of the Earth. He calculated it as 23 hours, 56 minutes and 4.1 seconds. This is unbelievably close to the modern day calculated value of 23 hours, 56 minutes and 4.091 seconds, representing an error of merely 0.09 seconds. He also estimated the length of the year to be 365 days, 6 hours, 12 minutes, 30 seconds, which only deviates from today's calculations by 3 minutes 20 seconds. Similarly, Aryabhat calculated the value of the sidereal year, the length of the year, to be 365.25858 days, as compared to the actual length of a year calculated today, which comes out to be 365.25636 days. These calculations by Aryabhat were one of the most accurate calculations in the world till that time. He was the first to explain that moon and planets shine due to the reflected sunlight. Even with the lack of any accurate astronomical instruments at that time, Aryabhat was able to successfully deduce that the Earth is round and revolves around its axis. Furthermore, he connected this with the existence of the day and night. Aryabhat used a geocentric model for the solar system in which the sun and moon are each carried by epicycles which in turn revolve around the Earth. However, despite using a geocentric model, Aryabhat correctly explained how the moons and planets have no light of their own but shine due to the reflection of sunlight. Furthermore, he corrected the flawed belief that eclipses are caused due to the two demons, Rahu and Ketu, and explained that they are caused due to the shadows of the Earth and the Moon, and described how to calculate their timing and their size. The computational model of Aryabhat was so accurate that in the 18th century, scientist Guillaume Le Gentil found his calculations regarding the duration of the lunar eclipse of 30th August 1765 to be short by only 41 seconds. Isn't it amazing? He explained how movement of celestial bodies was due to rotation of the Earth. Aryabhat explained how the Earth moves around its axis, and he also explained how the apparent movements of the stars in the night sky is, in fact, relative motion that is caused by the rotation of the Earth. This struck the popularly accepted view of the time that this was caused by the rotation of the sky. All this and more is mentioned in the very first chapter of Aryabhatiya, where Aryabhat calculates the number of rotations of the Earth in a yuga, one of the 4 eras defined in Hinduism. He writes, in the same way that someone in a boat going forward sees an unmoving object going backwards, so someone on the equator sees the unmoving stars going uniformly westward. The cause of rising and setting is that the sphere of the stars, together with the planets, apparently turns due west at the equator, constantly pushed by the cosmic wind. He authored another influential text titled Arya-Siddhanta. Aryabhatta also penned another major work on astronomical computations known as the Arya-Siddhanta. However, this has been lost through the ages. The Arya-Siddhanta came into light primarily through the works of astronomer Varahamihir, who was Aryabhatta's contemporary. Later, it was also picked by famous mathematicians such as Brahmagupta and Bhaskara I. Arya-Siddhanta makes use of the midnight day reckoning and is based on the older Surya Siddhanta. There is a special chapter named Yantradhyaya. The work covers some of the major astronomical instruments of the time, including the perfect circular shadow instrument, Chaya Yantra, angle measuring devices, semicircular and circular devices, Dhanur Yantra, Chakra Yantra, umbrella shaped device, Chhatra Yantra, a cylindrical stick, Yashti Yantra, and water clocks that include bow-shaped and cylindrical designs. Let us see some of these instruments. A Gnomon, Shanku Yantra, is the part of a sundial that casts a shadow. The term is used for a variety of purposes in mathematics and other fields. A water clock is any timepiece by which time is measured by the regulated flow of liquid into or out from a vessel where the amount is then measured. A third text which may have survived in the Arabic translation is Al-Nan or Al-Nan. It claims that it is a translation by Aryabhatta, but the Sanskrit name of this work is not known. Probably dating from the 9th century, it is mentioned by the Persian scholar and chronicler of India, Abu Rehan al-Biruni. Additionally, Aryabhatta also been credited with setting up an observatory at the Sun Temple in Taregana. This observatory was built on a 20 feet high land at the Sun Temple that once existed in Taregana. It was from this observatory that he and his team used to gauge the stars.